That is surds. On this topic, surds, we shall talk about rational and irrational numbers. So I want us to start with rational numbers. When we talk about the rational number, it's a number which can be written in the form P over Q, where P and Q are integers, and Q is not equal to 0. Q is not equal to 0. Because if Q is equal to 0, then that means this will be equal to infinity. P over 0 will be equal to infinity. So Q must not be equal to 0. It should not be equal to 0. So the integers P and Q must not have a common factor other than 1. P and Q must not have a common factor apart from 1. For instance, a common factor, that means if we are talking like P over Q, if we talk about, for instance, if I talk of 2 can be over 1. So 2 over 1 is a rational number because 2 can be written as 2 over 1. So 2 is a rational number. And the common factor here is only 1. What about if we talk about 2 over 4? 2 over 4, unless you simplify to be 1 over 2 and therefore becomes a rational number. Now 2 over 4 is not a rational number, it's irrational because it has what we call a common factor. It has a common factor. So it has a common factor. It's not even irrational. It is not rational because there is a common factor of 2. So there is a common factor of 2, it's not irrational because irrational numbers have square roots. They cannot be written in the form P over Q. I'm going to explain that. So 2 over 4 is not a rational number because there is a common factor of 2. Common factor of 2. Apart from 1, there is a common factor of 2. So it's not a rational number. But 2 is a rational number because it can be written in the form P over Q and there is no common factor apart from 1. And therefore it is a rational number. So that is what we call rational numbers. Rational number, they can be written in the form P over Q, and the Q should not be equal to 0. And another condition is that there must not exist a common factor apart from 1. Numbers such as 2, half, 3 over 4, root of 4, because root of 4 is 2, are examples of rational numbers. Recurring numbers are also rational numbers. If we have some recurring numbers, are also rational numbers. Irrational numbers are numbers that cannot be written in the form P over Q. That's numbers such as root of 2, root of 3. Remember, root of 4 is not irrational because root of 4 is 2 and the 2 can be written as 2 over 1, which is P over Q. N number with a square root is not a rational number but irrational number. Root of 6 is an irrational number. Root of 5 is an irrational number. Root of 7 is an irrational number. Root of 8 is an irrational number. But the root of 9 is not an irrational number but a rational number because root of 9 is 3 and the 3 can be written in the form 3 over 1, that is B over Q. So you should understand all that what you need of rational numbers and irrational numbers. And after understanding rational numbers and irrational numbers, you will now be able to understand what we mean by surds. When we talk about a surd, these are numbers which have got no exact square root or a cube root. They have no exact square root, cube root, fourth root, fifth root. They do not have exact roots. And therefore, we call them surds. Example is root 2. There is no exact root. Root of 8. There is no exact root. Root of 28. No exact root. Cube root of 3. Cube root of 16. There is no exact root. Cube root of 16. There is no exact root. Cube root of that 6. We don't have exact root. But when we talk about cube root of 8, there is an exact root of 2. So a number that do not have an exact root is what we call a surd. The product of surds and rational numbers is called a mixed surd. If we have a rational number like 2 root 3, so this is a mixed surd. A rational number like 4 over 1, root 7 is a mixed surd. If we have 1 over 3, because it is in the form of P over Q, 1 over 3 is a rational number, root 2 is an irrational number. So mixture of a surd, and we know a surd is a square, mix of a surd and a rational number, we call it a mixed surd, like 1 over 3, like all this that I've explained. So that is what we call mixed surds, and that is what we call a surd. A surd is number that do not have exact root, either square root, cube root, fourth root, fifth root. As long as it does not have an exact root, we call it a surd. We call it a surd. Now, let's talk about order of surds. Order of surds, like root 3, root 6 are surds of order 2 because the root is just a square root, meaning they are of order 2. Cube root will be order 3. Cube root will be order 3. Fourth root is order 4. Fifth root is order 5, and so on. So when we talk about simplification of surds, I want to show you on how to simplify surds. Simplification of surds, for instance, if a surd can be reduced to its lowest term possible as follows. That is an example. If you are given like simplify the root of 18. If you are asked to simplify the root of 18, first of all you think of two numbers. One must have a square root that you multiply. That is the factors of 18. Factors of 18 we can talk about 9 times 2. This can be equal to 9, the root of, this can be equal to the root of 9 times 2. 9 times 2. And 9 times 2, this is the same as the square root of 9 times the square root of 2. The square root of 9, if you separate them, times the square root of 2, times the square root of 2. Now, we know that the square root of 9 is 3. Square root of 9 is 3. Times the square root of 2, so 3 root 2. 3 root 2. So 3 root 2 is the simple form of root 18. If you are asked to simplify the root of 18, you get it as 3 root 2. 3 root 2. That is how you simplify root 18 as 3 root 2. As 3 root 2. So you think of factors, the factors of 18, so that you multiply them under square root, then you separate so that you get the square root of 1. So you must find one number that has a square root for you to simplify. That has a square root for you to simplify. So that is how we simplify. Now, the square root of 72. How do we simplify? Square root of 72. I think of two numbers that I multiply there. Square root of 72, it can be equal to, like I've said, it is the root, it's the same as the root of 36 times 2. I know somebody can think of 9 times 8. Yes, if you think of 9 times 8, remember 8 can be further simplified as 4 times 2. So still you arrive at the same answer, but you shall have gone a very long route. A very long route. So you think of a number, two factors of 72, which is 36 times 2, and 36 as a square root. So it will be equal to the root of 36. Root of 36 times the root of 2. The root of 2. So this is the same as root of 36 is 6. The root 2. It's the same as 6 root 2. 6 root 2. So you find it is 6 root 2. That is how you simplify the root of 72. The root of 72 becomes 6 root 2. So that is how you simplify it. That's how you simplify it. And if you wanted to go back, remember you square this, you bring it here. 36 times 2 becomes root of 72. So if you wanted to go back. So that is how we simplify. We simplify surds. Simplification of surds. That is how we simplify surds. That is how we simplify surds. Like root of 18 and root of 72, I've explained about them. Operation of surds, surds can be added or subtracted. They can be added, surds can be added or subtracted only if they are like surds. That is, if they have the same value under the root sign. That is, like if I talk of let me talk about like m root of a plus n root of a. So we must have the same number under the root. If it's cube root, it must be cube root. But we cannot add. This is m root a plus n root a, so it becomes m plus n root of a. Root of a, yeah. So meaning that I cannot add like a cube root of a plus square root of a. This cannot be. I've said cannot be added. Cannot be added. Cannot be added. Be added. This cannot be added because these are cube root and this is square root. They are not same surds. They are not of the same order. So they must be of the same. Surds can be added or subtracted only if they are like surds. That is, they have the same value under the root sign. Under the root sign, same value under the root sign, and they must be of the same order. If they are not of the same order, you cannot add or subtract. You cannot add or subtract. We shall talk about multiplication and division, but for addition, they must be of the same order. They must be of the same order and must have the same value under the root. It must have the same value under the root for you to add or subtract. Example, simplify the following. You simplify the following. 3 root 2 plus 5 root 2. This one you can easily add because they are of the same order and they have the same surds. They are the same surds. This side 2 and this side 2. So it is 3. If we let, you can say, for you to understand better what I mean, if I let root of 2, because they are common, if I let root of 2 to be equal to x, if I let root 2 to be equal to x, so that means this will be 3x. It implies that this is 3x, this is 3x plus 5x because root 2 is x, which gives you 8x. That gives you 8x. That gives you 8x. Now I can substitute x with root of 2, which becomes 8 root 2. 8 root of 2. 8 root of 2. So that is how we simplify 8 root of 2. That is how we simplify 8 root of 2. So that is how we simplify. That's how we simplify. You can also simplify like 8 root 5 minus 2 root 5. So it is 8 minus 2. That is 6 root 5. So the answer is 6 root 5. The answer is 6 root 5. Like I've said, you can let, that is Roman 2, because I've done Roman 1. I said I read root 5 in this case, the root of 5 to be equal to a or to be equal to x. So that means this will become it implies 8a minus 2a, this gives you 6a, but I know a is root 5, which is equal to 6 the root of 5. So that is how we simplify. Let's talk about multiplication and addition, because for multiplication and division, for addition and subtraction, we have learned that for you to be able to add, they must have the same surds and they must be of the same order. If they are not of the same order and do not have the same surds, you cannot add or subtract surds. For multiplication, what you need to note is that surds of the same order can be multiplied or divided irrespective of the number and the root sign. Remember, as long as they are of the same order, they must be of the same order, but the number under the root sign does not matter. But for addition and subtraction, the number under the root sign matters. Like if it is root 2, it must be root 2 and another one root 2. If it is root 6, it must be root 6 and another one root 6. But for multiplication and division, the number under the root does not matter as long as the order is the same. Meaning, that one means that we can multiply like the root of a times root of a, they are of the same order. Root of a times root of a equals to, because they are of the same order, equals to root of a times a. It equals to root of a times that is a times a. Or we can talk about root of a. Remember, now we have a root times root of b, but the number under the root are not the same. So you can say times root of b. You can still multiply because they are of the same order. It is this becomes root of a times b. Root of a times b, because they are of the same order. But you cannot multiply. You cannot multiply like cube root. If I talk of cube root of a times the square root of b, they are not of the same order. They are not of same order. They are not of same order. And if they are not of same order, and if they are not of the same order, meaning we cannot multiply or divide. Division is the same. Root of a divided by root of a equals to root a over a, or a divided by a, and the root of a divided by root of b is the same as root of a or over b. So you can, as long as they are of the same order, the number and the root does not matter. But you cannot multiply if they are cube root of a times root of b. You cannot multiply because the order is different. The order must be the same for you to multiply or divide. For you to multiply or divide, the order must be the same, but the number under the root does not matter. The number under the root does not matter on division and multiplication, unlike the addition and subtraction. Each year I've said root A and root B can be multiplied and be divided. They can be multiplied and divided. But as I've explained that root of A can't be multiplied or divided by cube root of A can't be multiplied or divided by root of A because they are of different order, like I have explained. Now, multiplication and division laws of surds. We need to get some laws of surds. Like law 1, root of A times root of B equals to A times B. E.g. root 3 times root of 12 is equals to 3 times 12 root. That is root 3 times 12, which gives you root of 36, which is equal to 6. Law number 2 is that root A divided by root B or root A over root B equals to the root of A over B. That is e.g. root of 12 divided by root of 3 is the same as root of 12 over 3, which is equal to root of 4, which gives you 2. Law number 3, you need to understand that the root of A squared or root of A bracket squared is the same as A. If a root, like for instance, root of 12 squared, remember the square cancels with the root, which gives you 12. It's like even if it's cubed, like root of A cubed is the same as A. Cube root of, that is cube root of A cubed. Cube root of A cubed is still A. Cube root of A cubed is equals to A. So it's the same, or fourth root of A power of 4 equals to A. So you need to understand that law. Rationalization of the surds. We should now understand on how to rationalize surds. Surds may also appear in fractions. Rationalizing the denominator of such a fraction means finding an equivalent fraction that does not have a surd on the bottom of the fraction, though it can have a surd on the top. If the surd contains a square root by itself or a multiple of a square root, to get rid of it, you must multiply both the top and the bottom of the fraction by the square root value. E.g., 6 over root of 7, we multiply by root of 7 at the numerator and the denominator for us to remove the root in the denominator. So that is what we call, when it is just the root of a root at the denominator, we remove the root at the denominator by multiplying it at the bottom and the top. So if I multiply 6 times the root of 7, or over root of 7 times root of 7, remember I said that root of A squared equals to A. So root of 7 squared, root of 7 times root of 7 is equals to 7. So this 6 root 7 out over 7. So that is how we have rationalized the denominator. This is now rationalizing the denominator. And if the surd on the bottom involves addition, if there is an addition or subtraction with square roots, to get rid of the square root part, if you want to get rid of the square root part at the denominator, at the root part, you must use the difference of two squares. We use the difference of two squares. Remember, difference of two squares in form 2, we write that difference of two squared, A squared minus B squared, that's the difference of 2 squared, we said equals to A plus B into brackets A minus B. You run that in form 2, the difference of 2 squares. This is what you run. So we shall apply this one to eliminate the denominator, to eliminate the surd in the denominator. And then you multiply both the top and the bottom of the fraction by the bottom surds. You multiply both the top and bottom of the fraction by the bottom side expression, but with the different inverse of operation. That is, we conjugate the denominator. What do we mean by conjugating the denominator? We have said with the inverse operation, meaning that if it is 2 plus root of 2, now the conjugate of this fraction, it is 2 minus root 2. That is the opposite. If it was 2 minus root 2, then the conjugate of the denominator, it is 2 plus root 2. So that is what we mean by conjugating the denominator. So an example is that we simplify or rationalize the denominator in 7 over 7. If the question is 7, if the question is 7 over 2 plus root 2, we need to conjugate to rationalize. If you're asked to rationalize here, I've said we multiply 7, we multiply by the conjugate, and the conjugate is 2 minus root of 2, 2 minus root of 2, all over, now we have 2 plus root 2, 2 plus root of 2, that is times its conjugate, which is 2 minus the root of 2, that is the conjugate of the denominator. So if we multiply this, so that we get this times 7 times 2, we get is 14. So this gives you 14 minus 7 root 2, so minus 7 the root of 2, 7 root 2, all over. Remember, this one is the difference of 2 squared. We said a plus b into a minus b equals to a squared minus b squared. A squared, my a is 2 and my b is root 2. A squared is 2 squared, which gives you 4, minus b squared is root of 2 squared, which gives you 2, because we said root a squared equals to a. So this gives you 14 minus 7, 14 minus 7, this gives you 14 minus 7, the root of 2, 7 root 2, all over 2. We can separate, that gives you, we separate each part of the, we separate each part, it will be 14 over 2, 14 over 2, then minus 7 over 2, 7 over 2 of root 2. Remember, this gives you 7 minus 7 all over 2 of root 2. That is rationalizing the denominator. That's how we rationalize the denominator. This is how we rationalize the denominator. So rationalizing this one gives you this. You should know how to rationalize so that you get it in the form a plus b root c. A plus b root c. So you should know on how to rationalize the denominator. We should know on how to rationalize the denominator. We should know on how to rationalize the denominator. So that is how we rationalize the denominator. Rationalize the denominator. That is how we rationalize the denominator. Rationalization of the denominator. Now we want to talk about another example. That is questions. Now we should solve these questions for us to be able to understand the topic better. Like if you are asked to simplify by rationalizing the denominator, we have said that we find the conjugate of the denominator, and the conjugate of the denominator here is root 6 plus root 3. So that is this will be equal to the root of times the conjugate in both the numerator and denominator. So it will be the root of 2 plus root 3 plus root of 3 plus root 3, then times the conjugate, and the conjugate is root of 6. The conjugate is root 6 plus root 3, root of 6 plus the root of 3, root of 6 plus root of 3 is the conjugate, all over the denominator, which is root of 6, root 6 minus root 3, that one times its conjugate, which is root 6 plus root 3, root 6 plus the root of 3. So we multiply the same. In the numerator we will get as 2 times, remember we expand this. If we expand this, we will get as root 2, this first one, into brackets of all this, into brackets, root of 6, root 6 plus the root of 3, this one, then plus, because there is this addition, plus root of 3 into brackets, all those, that's root 6. That's how we expand. You remember it in form 3, the expansion part, that is root, even form 2, we learned on how to expand. So root 3 into root 6 plus root of 3 plus root of 3. We want to see now how to expand all over. These are difference. Mostly the conjugate becomes now the numerator, the denominator becomes the difference of 2 squares, which is now a squared minus b squared. That is root 6 squared, which gives you 6, minus root of 3 squared gives you 3. So this will be equal to, we expand here, it becomes this 2 times 6, which is root of 12. This gives you root 12. This gives you root 12, this and this, plus root 6 plus root of 6 plus root of 6 plus root of 6, then plus root of 18 plus root of 18 plus the root of 18, because 6 times 3 is 18, then plus root of 3 times root of 3 is 3. When you look here, there is no like terms. There is no like terms unless you simplify here. Remember this one, if you simplify this 9 times 2, it is 9 times 2 gives you, and this one, can you simplify? Yes, 4 times 3. Yes, 4 times 3, so all over 3. So that means if I simplify this, it is 4 times 3. 4 times 3, 4 has a square root of 2 root 3, plus, that is a mixed surd, plus, you make it a mixed surd, plus, this one you cannot simplify, root of 6 you cannot simplify, root of 6, then plus, remember this is 18, and 18 has 9 times 2, so 9 has a square root of 3, root of 2, 3 root 2, then plus 3. All this all over 3. If you want, you can separate so that you have 2 over 3 root 3 plus a third root 6 plus 3 and 3 will cancel, will be plus root what? Plus root 2, then plus 1 if you wanted. But even if you leave at this point, you are correct. Leave at that point, you are correct. So that is how we simplify. Now here, question number 2, if root of 14 all over root 7 minus root 2 minus root 14 over root 7 plus root 2 equals to a root 7 plus b root 2. Find the value of a and b where a and b are rational numbers. Now what you do in this case, there are 2 ways of doing it. You can rationalize each part of this, each part of the equation. This part you rationalize separate and this part you rationalize separate. And then you equalize whatever you will find after rationalizing each part, whatever you will find will be equal to this. Or you just work out the way we were doing fractions in Form 1. We find the LCM. So if I find the LCM in this case will be this times this. The LCM will be the root of 7 minus root 2 then times root of 7 plus root 2 plus root 2. So I find this one comes to the LCM how many times? Remember this and this cancels, it comes this times. So this times root of 14, it becomes the root of 14, root of 14 into this one which is root 7 into bracket root of 7 plus root of 2 plus root 2. You close that bracket because we're multiplying. Then minus, because these are minus, so minus brackets minus. Now we have root is 14, the root of 14 into brackets. This one comes here how many times? This and this cancels, comes here these times. So into brackets root of 7 minus root of 2, root of 7 minus root of 2, which is equal to now we remember this is the difference of 2 squared. This will be 7 minus 2, which is 5. Now we open here the bracket. This becomes 14 times 7. 14 times 7 plus, that is root of 14 times 7. The root comes the root of 14. Comes the root of 14 times 7, that is comes the root of 98. The root of 98 root of 98 plus root of 28 plus the root of 28, and then minus this 14 root of 98 minus the root of 98 root of 98 minus root of 98, because this minus, then minus, and this becomes positive now, plus root of 28 plus this, and this gives you the root of 28. That is 14 times 2 all over. Remember, I've said this squared minus this squared, which is 7 minus 2, which gives you 5. 7 minus 2. This will be equal to root of 98, and root of 98 becomes 0, and root 28 plus root 28, it is 2 root 28. 2 root of 28 all over 5. All over 5. And the root of 28, can you simplify root of 28? 28, if I think of two numbers, it can be what? 28 can be 14 to 7 times what? 7 times, if I think of 7 times 4, 7 times 4 can give me, 7 times 4 can give me 28. 7 times 4 is 28, and 4 has a square root. So 2, square root of 4 is 2. 2 comes out, so 2 times 2 is 4. So it will be equal to 4 root of 7, 4 all over 5, the root of 7. Now we have said that it is equal to a root 7 plus b root 2, a root 7 plus b root 2. Do we have a root 2 anywhere? Plus b root 2. That means b is what? Because there is no root 2. So if there is no root 2 here, that means b is 0. Our b is 0. So find the value of a and b, where a and b are rational numbers. So a is what? A is 4 over 5. It implies that a, because a root 7 require this one, so a equals to 4 out of 5, and b equals to 0. B equals to 0. So this is how you want to solve this question. This is how you want to solve this question. By rationalizing, you can either rationalize each part or you find the LCM. But what you'll find after solving, you'll still find 4 over 5 root 7. You will find 4 over 5 root 7. So whichever route you go, you'll get the same answer. You will get the same answer. You choose the best for you, and you can even do the same question using the other way that I've told you, so that you see whether you find the same answer or there is a miscalculation somewhere. Just follow the same procedure, the one I've said, that you rationalize each part. After rationalizing each part, you see whether you get the same answer with finding the LCM. But you're supposed to get the same answer by whichever method that you follow. You are supposed to get the same answer. You're supposed to get the same answer. You're supposed to get the same answer. Now I want to do another example. We do another example. That's question number 3. We simplify as far as possible, leaving your answer in form of a surd. Simplify as far as possible. Now here, I said that you can rationalize each part separately, or you find the LCM. So if I decided to go the LCM way, I'll find the LCM of this. I'll find the LCM. I'll find the LCM of this to be root of 14 minus root 2 minus 2 root 3 minus 2 root of 3. Whatever you get, you multiply by root of 14. Root of 14 plus 2 root 3 plus 2 root of 3 at the LCM. So this one comes here these times. So it will be 1 into these times, that is root of 14 plus 2 root 3 plus 2 the root of 3, then minus this one comes here these times, so minus 1 into brackets root of 14, that is root of 14 minus 2 root 3 minus 2 minus 2 the root of 3, 2 root 3 over this. So this gives you now we have 1 times this root of 14, the root of 14 plus 2 root 3 plus 2, that is 1 times 2 root 3, this is 2 root 3, 2 root of 3, then minus root of 14, that's 1 times that gives you root of 14, this minus and this minus gives you positive, that is plus 2 root of 3 all over, this is the difference of two squares, so it is this squared minus this squared. This squared gives you 14 minus this squared gives you already, this is 4 because 2 squared is 4 times 3. 4 times 3 is 12, so it's minus 12. So this gives you, like times together, this and this will cancel because root 14 minus root 14 is 0, and this plus this gives you 4 root 3. This 4 the root of root 3, 4 root 3, that's root 2 root 3 plus 2 root 3 is 4 root 3, 4 root 3 all over, this gives you 2. 2 cancels here once and 2 comes here 2 times. So this will give you 2 the root of 3, 2 root of 3. So if you simplify this is what you are supposed to get. 2 root 3 is the answer. 2 root 3 is the answer. Now you are given a question like, given that tan of 75 is 2 plus root of 3, find without using tables tan of 15 in form of p plus q root m, where p and q and m are integers. Now what you do, tan of 75, you draw a right angle triangle. A right angle triangle. Remember this is 90. This is 90. If I have 90 here, so I talk of these as 75. This is my 75 degrees, so that means, remember this is 90, so whatever was remaining was 90 because our angle, some angle of a triangle add up to 180. So 75, there is an angle here that would that makes 90. So 90 minus 75 gives you 15. So this is my 15 degrees. My 15 degrees. So if that is my 15 degrees, and I know that given the tan of 75, TOA, so TOA, we talk about TOA, that is tan theta equals to TOA equals to opposite tan of theta equals to opposite tan of theta equals to opposite all over TOA all over adjacent. I have explained from previous lessons that like this 75, the opposite of 75 degrees is this line, and the adjacent to it is this line. The opposite of this is this line, and the adjacent to it is this, because this is the hypotenuse. So when we talk about tan of 75, remember this is opposite tan of TOA, this is the opposite all over the adjacent, which is 1. So in the opposite of 75 is 2 plus root 3 is here, 2 plus the root of 3 plus root 3 is here, and here is 1, TOA. So we can easily find the hypotenuse, and our hypotenuse now, if we talk about the hypotenuse will be equal to this squared plus this squared is square root. Remember, this squared is 1 plus this squared, then we find the square root. So 1 plus, because 1 squared, okay, 1 squared plus this squared, 2 plus this squared, 2 plus the root of 3 squared, we find the square root for us to find the hypotenuse. The whole thing, we find the square root for us to get the hypotenuse. So the hypotenuse is what? I can expand this one. If I expand this is you can use a principle that we say a plus b this squared. You can expand or just use this principle equals to a squared plus b squared plus 2ab, I mean, plus 2ab plus 2ab, a squared plus 2ab, then plus b squared plus b squared. So if I use the same principle, this becomes the square root of 1 plus this squared, which is 4, plus 2ab, 2 times 2 times this, that is 2 times 2 is 4, times this is 4 root of 3 plus 4 the root of 3, then plus, remember we say it is plus b squared. This b squared is 3. This is equal to the square root of, remember this plus this is 5 plus this is 8, so it is 8. This is 5 plus there is 8 plus 4 the root of 3. That is my hypotenuse. So if I separate this, this gives you the root of 8. Root of 8 I can now 8 is 4 times 2, and 4 as a square root, so it will be 2, 4 as a square root of 2, 2 root of 2, then plus, remember I'm finding the square root of the whole thing here, if I find the square root of the whole thing here, the square root of 4, the square root of 4 is what? The square root of 4, remember I'm finding, let me just write, plus the square root of 4 times the root of 3. Remember, this is the square root and this is the square root. So we shall have root. So it becomes root. So we shall have here 2, because the root of 4 is 2. So this gives you 2 root 2, the root of 2, to the root of 2 plus 2 plus 2 root of 3. It becomes the fourth root of 2 fourth root of 3, 2 fourth root. That's root times the root, fourth root, because root of root 3. If you talk about square root of root of 3, it gives you yes, the root of 3, yes, it gives you 2 times the fourth root of 3. Yes, fourth root of 3. If I talk about fourth root of 3, yes, so it's the same as fourth root, because the root it becomes fourth root. 2 fourth root of 3. 2 fourth root. 2 root 3 is 2 root of 3, 2 root 2. That is my hypotenuse. But anyway, I was not interested with the hypotenuse because I'm talking about that we find the tan of 15. So there was no need of going all that, because if we ask you to find the sine of 15, the sine or the cosine, now we need the what? Because so we need the hypotenuse. That's when you could have found the hypotenuse so that you find this. But in this case, we are not been asked the sine. So now that we are talking about the tangent, we are talking about the tangent of 15. We are talking about the tangent of 15. We don't need to find the hypotenuse because we are complicating the idea. So what you do, if you are asked to find the sine, now you deal with it so that you get the sine of 15 degrees is opposite now of 1 over hypotenuse 2 root 3 plus 2 cube root of. So the sine, if we are talking about sine of 15, sine of 15 degrees equals to the opposite of 15 is 1 all over hypotenuse. So all over hypotenuse, which is 2 root 2, I've said is 2 root 2 plus 2, then fourth root of 3. So all over 1 all over 2 root of 2 plus 2 plus 2 fourth root of 3. So So that is the sign. But we are talking about tan of 15 because that is our interest. Tan 15 degrees equals to twice the opposite of adjacent. The opposite is 1 all over adjacent, which is 2 plus the root of 3. But we ask you to get it in this form, so that means we rationalize the denominator. Rationalizing the denominator, it becomes 1 times the conjugate, which is 2 minus the root of 2 minus the root of 3, 2 minus the root of 3, 2 minus the root of 3, then all over that is 2 plus root of 3, 2 plus root of 3 times its conjugate, which is 2 minus the root of 3. This will be equal to, we remain with this 2 minus the root of 3 all over this difference of 2 squared, which is 2 squared minus root 3 squared, which is 2 minus all over this squared. 2 squared is 4 that gives all over 4 all over 4 minus root of 3 squared is 3, which gives you 2 roots. 2, that's over 1. Remember, it will still be remaining as 2, which is equal to, it remains as 2 minus the root of 3, because all over 1 it remains that the root of 3. The root of 3. So P is 2 and Q is 1. Q is 1 and M is root 3. So these are the P as 2, Q1 and M root of 3. So that is how you are supposed to do. Tan of 15 degrees gives you 2 minus root of 3. 2 minus root of 3 is the tan of, that is the tangent of 15 degrees, the tangent of 15 degrees. But if you're asking about the sine, the cosine, that means you find the hypotenuse. But in this case, you were not asked to find that, you were asked to find the tangent of the 15. So there was no need of finding the hypotenuse that I have found. So there was no need of finding the hypotenuse that I have found. You are only required to deal with the tangent. So that is how we solve these questions when they involve the angles. Now simplify this, give your answer in form of A. So we rationalize the denominator in this case, like I've said before. We rationalize it, so it will be this one. You are not rationalizing in terms of you are rationalizing, but you multiply with us the root of 3 times root of 3, both the numerator and denominator, because there are no involved the additional subtraction, so that you find the conjugate. So you just multiply root of 3 and root of 3 and then simplify. For this one, you find the conjugate, you multiply it on the numerator and denominator for you to get the answer. So those are some of the questions that I like you to do during to see whether you've understood this concept. And that is the end of my tutorial. And remember to subscribe for me. I am Mwalim Ogeke. Thank you for listening to me.